In this video, I'm going to show you how to do typical limiting reactant problems. A limiting reactant is the reactant in a chemical reaction that is used up first. So it runs out, and that limits the amount of product that can be formed. And the way that we usually find the limiting reactant is that we're given the amounts of both reactants in a chemical reaction. And then we calculate using stoichiometry how much of the product can be formed. So let's take a look at this example. In this reaction, we've got calcium carbide plus water makes calcium hydroxide and acetylene gas. And so if we're given the amounts of both reactants, and this is usually how you can spot a limiting reactant problem, is you're given the amounts of both of the reactants and you want to know how much of one of the products you can form. And usually it's the product that you're interested in or that the problem asks for. So in this problem, we have 10 grams of calcium carbide and 10 grams of water, and we want to know how much acetylene can be formed in this reaction. So we're going to have to start using the 10 grams for each reactant and then calculate how much of the product can be formed, and then whichever one gives the smallest amount of product, that reactant is the limiting reactant, and that amount of product is the theoretical yield. So let's do the first calculation. Let's start with calcium carbide. We've got 10 grams of calcium carbide. Convert that to moles, divide by its molar mass, which is 64.1 grams. That's 1 mole of calcium carbide. And here's where we do our stoichiometry step, the mole-to-mole ratio. So we cancel out moles of calcium carbide and we're converting to moles of acetylene, and it's a 1-to-1 ratio from the balanced equation. And then 1 mole of acetylene has a mass of 26.04 grams. So starting from calcium carbide, we would make 4.062 grams of acetylene. So in this type of problem, we have to do the calculation twice. So let's also start with water and calculate how much acetylene that would form. So 1 mole of water is 18 grams. And in this reaction, we have a 2 in front of water. So 2 moles of water form 1 mole of acetylene. And then the last conversion factor is the same. In both, we're just multiplying by the molar mass of acetylene. So starting with 10 grams of water, we can make 7.225 grams of acetylene. So that means that calcium carbide is the limiting reactant. And so this is the theoretical yield. That's the maximum amount of product that can be formed. And so that means that calcium carbide is the limiting reactant. And you might also hear the word limiting reagent. It means the same thing. So theoretical yield is 4.062 grams, and calcium carbide is the limiting reactant. So whichever one makes the smallest amount of product, that's your limiting reactant. So another question you might see is, what is the percent yield if some amount of product is actually formed? So if 3.79 grams of calcium carbide is actually produced, then what is the percent yield of the reaction? So the percent yield is the actual yield divided by the theoretical yield. And we just calculated the theoretical yield in the limiting reactant problem, and the actual yield is given, it's 3.79 grams. So you can just plug those numbers in and calculate the percent yield. And so usually you'll have to do the theoretical yield calculation first. So 3.79 grams divided by the theoretical yield, 4.0 4.062 grams gives you a 93.3% yield. So that's a good yield for any reaction in chemistry. Another question that you might be asked is how much of the excess reactant is left over. So in this calculation, you start with, there are actually a few different ways to do this, but let's start with the amount of product that would be formed, the theoretical yield, 4.062 grams, and then we can back calculate how much of the excess reactant was required to make that amount of product. So let's convert that to moles. So 4.062 grams of acetylene, 1 mole of acetylene has a mass of 26.04 grams. So now we have that in moles, and let's convert that to moles of water. So 1 mole of acetylene gives 2 moles of water, and then 1 mole of water has a mass of 18.02 grams. So we do that calculation, and you get 5.622 grams of water. That's how much water is required to react with that much acetylene. So we take the original mass of water, subtract the amount of water that reacted, and that gives you the amount of the excess reactant left over. So we have 4.38 grams of water left after that reaction.